We're solving problem 2 from the 2024 F equals MA exam. An amusement park ride consists of a circular horizontal room. The rider leans against its frictionless outer walls, which are angled back at 30 degrees with respect to the vertical, so that the rider's center of mass is 5 meters from the center of the room. When the room begins to spin up at its center, at what angular velocity will the rider's feet first lift off the floor? This is basically one side of the room where this dot denotes the rider's center of mass. And it's 5 meters from this pillar or this line, which simply means it's the center of the room. Now, there are 3 forces acting on it: the normal force, the vertical force, and the horizontal force. Since this angle of 30 corresponds to this one right here, as you draw the vertical force from the center of mass, since the normal force always has to be perpendicular to the surface it's acting on, we know that this angle is 60 degrees. And, well, the problem also says you want to find the angular velocity when the rider's feet lifts off the floor. Well, the feet lifting off the floor, it has to do with the vertical force. So we can set an equation for that. This is equal to, well, that would be n sub the normal force times the cosine of theta. And how does this exactly relate to what I just said about the rider's feet lifting off the force? Well, the force acted by gravity, or the gravitational force acting on the person, is equal to their respective mass times the force of gravity, which is like 9.8 meters per second. But we just denote it by gravity, and in this test, we substituted it as 10. Why does that matter? Because when the rider's feet lift off the floor, this means that the vertical force and the gravitational force are equal, as there is not an unbalanced force on the rider. So this is mass times gravity. Therefore, dividing both sides by cosine of theta, we get that normal force is equal to mass times gravitational force over the cosine of theta. This is our first step, setting trigonometric identities up and finding out the lengths. Now, we can do the same for this horizontal. The horizontal force, denoted by n of 8 sub h, is, well, if this one's cosine, this is the normal force times the sine of theta. And since we already have an expression for the normal force, we can go and plug that in right there. So this is equal to mg over cosine theta times sine of theta. Well, this is mg, can be factored out as sine of theta over cosine theta. Well, sine of theta over cosine theta, that's simply the tangent of theta. And this horizontal force is basically the centripetal force acting inward, and we have an expression for that, an equation. The centripetal force is given mass times omega, which we're trying to find, squared times the radius, where the radius in this case is 5, as it's from 5 meters from the center of mass. We can set these equal to each other. mg times tangent of theta equals m omega squared times r. These m's cancel, and since we're trying to find omega, we divide both sides by r and take the square root of that. So omega is equal to g times the tangent of theta divided by r. Now, since we know the values of g and r, g is rounded up to 10 because that's what the rules say in this competition. 10 over 5 is simply 2. And we can finally plug theta back in, our angle of 60. So omega is simply equal to the square root of 2 times the square root of 3, since the tangent of 60 is the square root of 3. This estimates to about 1.86. But since we want to round up and the closest answer is rounded up, our answer is simply going to be 1.9.